Hey guys, welcome to the Level 2 NCEA Calculus paper from 2020. For those of you that are joining us for the first time, the way this video works is that I go through each question, tell you guys what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go by yourself, and then unpause the video just to see how far you actually came about with your answer. It's pretty much the same strategy that I use for every one of my videos. So without further ado, let's get started. All right, guys, so question one, what we've got here is your classic differentiate the equation and find out what the gradient is. So what are we looking for in this case? We're looking for the gradient at f when x equals to 4. So what we're looking for is f dash of 4, and we're trying to figure out what that is. So I need to differentiate the function first. So when I differentiate the function, x cubed differentiates to 3x squared, and then minus 2x squared differentiates to minus 4x. I don't really need to worry about the 5 because the 5 disappears into a 0. So now I need to find the gradient of it, of this function at 4. So I'm going to be replacing all the x's with 4. So I've got 3 times 4 squared minus 4 times 4. Now just chucking that on the calculator straight away. Where is it? There we go. I know I probably can do this in my head, but right now I just a little short on time and I don't want to be wasting time making silly mistakes. So there we go. 32 is the answer that I'm looking for. So this question is actually worth an achieved, and I think you have to get the correct solution to get an achieved. Normally, you have to also show the differentiated function step, so that is something to keep in mind. If you are wanting to get an achieved for the grade, you can't just give the answer by itself. Okay, so let's go to question B. So question B, what we have got here is we've got another function that's given by this. Find the x coordinate where the gradient is 5. Okay, so this is pretty much like a reverse of the previous question where we've been given the gradient and we were asked to find out what x is. So really, our question, if we summarize it, is because this is h of x, we want to know when is h of x equal to 5. Sorry, h dash of x. So we're going to have to differentiate the function. So h dash of x, when we differentiate it, we've got 0.5 times 2, which is going to be 1. So that's just going to be x, well, x squared. When you differentiate x squared, is going to become, you get what I'm trying to do there. 0.5x squared differentiates to x, and then 3x differentiates to just 3 by itself. So we've got x plus 3. Now, because this gradient function equals to 5, I'm just going to put this as 5 is equal to x plus 3. Rearrange it, so I'm going to get x equals to 5, take away 3, which gives me x is equal to 2. Yeah, I mean, you could just write that down here at the bottom, that x is equal to 2. And once again, this question is worth an achieved. And as I said before, you probably can't just guess and check. You would have to give the differentiated function. So not a bad way to start the exam paper. Kind of like a couple of neat little achieved questions to go start the paper. All right, so next we're getting up to question C. What we have is find the equation of the tangent. Okay, so it's a classic find the gradient and then put it in the equation of a line. All right, so our first step is we need to find the gradient when x is equal to 2. So I am going to do this. So, you know, you don't have to stick with y. I'm just going to rewrite this as f of x is equal to x squared plus 5x. Now, if I want to create the equation of a tangent, I need to use the equation of a straight line. So remember that that's y minus y1 equals m times, should have really went a little bit too far. Let's actually bring it in here. So m times x minus x1. So just to give you a bit of a heads up, these are things that we already have. So we actually got y1. So y1 is this point right here, which is 14. x1 we already have, which is 2. And the thing that we need to find is we need the gradient. All right, and to find the gradient, what we're going to need to do is remember that gradient when x equals to 2 is what we want to find out. So when is f of 2, that is the gradient. So our first thing is we got to find out what f dash of x is. I just realized I said f of 2, it should be f dash of 2. So f dash of x, so we're going to differentiate that function. So x squared differentiates to 2x, and then 5x differentiates to 5. Once we have this, we need to find the gradient at 2. So f dash of 2 equals 2 times 2 plus 5. That is equal to 9. So what we've just figured out is that our gradient is 9. So as you can see, I've got all the components that I need to create the equation of the tangent. So I'm going to write this down. Y minus y1 is 14. As I said, that's the point. M is the gradient, which is 9. And then I've got x take away x1, which happens to be 2. So at this point, all I got to do is just got to rearrange everything. So I've got y minus 14 equals, this is just expanded out. So what we're going to get is 9x minus 18. And then getting rid of that negative 14 to the opposite side, which will make it positive 14. And that gives me my equation of the tangent, which equals to 9x minus 4. Cool. So grades wise, we're looking at a merit for getting the tangent correct. Finds the gradient isn't achieved. So I would say getting up to here will get you an achieved grade. And also remember that you have to kind of show the differentiated function as well. It's just good habits. Okay, so let's go to question D. So with question D, what we have got here is, okay, so we've been given the gradient function and we've got P is a constant and it kind of goes through 2 points. Okay, so basically what we've got here, and I guess this is something to kind of remember. So the first thing is this, right? If you look at the gradient function, so I'm talking about this thing right here, and I'm just looking at the power of x. Now the gradient function is x, all right? So in other words, f dash of x is going to be a straight line, okay? I don't know which way it's going, but it's going to be a straight line. When I integrate this, I'm going to get f of x. Now because it's a straight line, when I integrate it, I'm going to get a parabola that either looks like this or it's going to look like this. The other thing is there's 2 points. So first we've got this 1 point here. Now let's just randomly, I'm just going to put randomly, maybe I shouldn't put it there, but I don't know, maybe somewhere there. And then my second point, let's say that's maybe not black. Let's try using this one here. And my second point, which is negative 6, 2, it might be there. I don't know. This is just like sketching it out just to kind of get an idea. So from this, I can see that my final answer is going to be a parabola, right? So it's going to be a quadratic. That much I know. So I guess the first step is I need to integrate f dash of x. So f dash of x right now is px minus 4. So when I integrate this, I'm going to get px. Now the power is going to increase by 1. So it's already, there's a 1 there. So it means 1 plus 1 is 2. Gets divided by the new power. And of course, minus 4x. Because anytime you have a number by itself and you integrate it, you're going to get x. And of course, don't forget the c. All right, this part is very important. Now, the issue is we've actually got 2 points and we also have 2 unknowns here. We don't know what p is and we don't know what c is. And I guess this is where you have to use, like, let's say you kind of don't remember this, but it's like, even if you don't know what to do, at this rate, what I would suggest that you do is set up 2 equations. Now the first equation is taking the values of 4 and 12. All right, so that's, we've got 4 and 12 as our first value. And then I'm just going to set that up first. So I know that when, this is just another way of saying f of 4 is equal to 12. All right, because when x equals to 4, y is equal to 12. So we're going to put that down. So we're going to get 12 is equal to px squared over 2. So p times 4 squared over 2 minus 4 times 4 plus c. We're going to simplify this now. So we're going to get 12 equals p. 4 squared is 16. 16 divided by 2 is 8. So that's going to become 8p. Minus 4 times 4 is negative 16 plus c. Obviously, I don't like that 16 there. I'm going to take it to the other side. And I've got 8p plus c. And on this side, I've got 12 plus 16. So kind of simplifying this, I'm going to get my first equation, which is 28 equals 8p plus c. All right, so that's my first equation. My second equation is I'm going to take my second point, which happens to be negative 6 and 2. And again, because this is negative 6 and 2, we can say f of negative 6 is equal to 2. And we're pretty much going to do the same thing as what we did for the previous point. So we're going to get 2 equals p negative 6 squared over 2 minus 4 times negative 6 plus c. Now when we do this, we're going to get 2 is equal to negative 6 squared is 36. 36 divided by 2 is 18. 18p. And then we got minus 4 times minus 6, which is positive 24, plus c. We're going to rearrange them, and so we're going to get 18p plus c is 2 take away 24. And so we've got negative 22 equals 18p plus c. So guys, at this point, what we actually have is a set of simultaneous equations. Now, in calculus, all right, and I do mean this, like, because you guys are allowed to use a graphics calculator, you can actually use the graphics calculator to solve for P and C in this case. So what I'm going to do is, and I'm fully aware, like some people would want to know this the long method. If you want to know this the long method, then I would suggest watching one of my simultaneous equations. Actually, no, you know what? I'll do the long method as well fairly quickly here. Just because I just looked at the values, they're pretty straightforward in this case. So my two equations are, I'm just going to kind of go here. So my first equation was 28 8p plus c. I am going to show you guys both methods here. So I'm going to write 8p plus c equals 28, and then 18p plus c equals negative 22. Is that right? Yep. So far, so good. Okay, so first method, doing it on the graphics calculator. So if you want to do it on the graphics calculator, go into menu, go down to equation, go into simultaneous equation. Number of unknowns in this case is 2 because you don't know what P and C is. I'm going to put down 2. And you literally write the coefficients of all those numbers. Now remember, C has a coefficient of 1 because it is 1C. So we're going to put this as 8, 1, and the number is 28. And our second one is we've got 18, 1, and negative 22. Chuck this in the calculator, and then we're going to click on solve or just press enter. And what we've been given is we've actually got two numbers here. Now remember that, you know how it says X and C? In our expressions, it's actually P and C. So in other words, we've got P. P is actually equal to negative 5, and C is equal to 68. Now you might be wondering, how do we know which one is P? So remember that if I go back here, so see how this is AX and BY. So for us, it's almost like 8P and 1C. So that this is how I know. So this is AX plus BY equals the constant. All right, so that's how I know that the X's are all equal to P and the Y is actually equal to all the C's. Hopefully that made sense, guys. So it's negative 5 and 68. Now, if you were to do this simultaneous equations, as I said to you before, these numbers are fairly straightforward. I'm not going to cheat. I'm just going to write it as it is. So because we've got both the C's here, you don't really need to manipulate any of the equation because we've got two C's there. All I'm going to do is I'm just going to subtract everything. So I'm going to go 8P minus 18P. C minus C, and then 28 minus negative 22. And I think that's really important that you see that negative 22 there. So 8P take away 18P is negative 10P. C take away C is 0. 28 take away negative 22, that means we've got to add them up together. We're going to get 50. So P is equal to 50 divided by negative 10, which gives us P is equal to negative 5. Now once we figure that out, we've got 8P plus C equals 28. So 8 times negative 5 plus C equals 28. We've got negative 40 plus C equals 28, and C is equal to 28 plus 40, which means C is equal to 68. Now, as you can see, you're going to get the same two answers, right? But the important thing is, like, you got to think about it. If you're doing 3 papers, you got to go, well, I don't really need to show the working for this. I can just do it straight in the calculator and just move on to the next question. I would probably say, that's what you should be doing, because doing simultaneous equations, while there's nothing wrong with it, it is also possible that like one little error could mean that you're not going to get a full merit grade. Now, in terms of merit grade, if you go back to the question actually says find the equation of the curve. All right, that's this part right here. So we still haven't written the equation of the curve. So we've got our equation, which is y is equal to px squared over 2 minus 4x plus c. So we do need to write that equation down. So p is equal to negative 5 minus 4x, and c is 68. And this is really important, guys, that you actually write the equation down, because if you don't write the equation down, then unfortunately you do not get a merit grade. So that's a merit right there. Integrates f dash of x correctly, gets you an achieved. So that's way back here is what you're going to do for an achieved. So a lot of work for a merit, as you guys can see, but that's why we kind of say, like, if you can actually use the graphics calculator to give yourself a slight bit of advantage, then why not? Cool. Let's go to the next question. The famous boat question. And I guess the reason I call it famous is because kinematics, right? Kinematics is always a good bit of fun. Now, the way I kind of work with kinematics, guys, I love drawing like little stink diagrams, but it just helps me see things in a different way. So I'm literally like, and I think whenever I do my kinematics tutorials, I always say this, draw a diagram. Draw like the most ugliest train or ugliest boat or whatever. So that's what I'm going to do here. All right, I'm gonna draw this out. So here is my port. Can't even write properly right now. So there's my port right there. We're going to have some water. Obviously, we're going to have some water right there. And what is it? The fishing boat is 80 kilometers from its port when it reaches its fishing grounds. Okay, so here is my fishing boat. A terrible boat. It's not even facing the other. This is what I mean by when I say bad drawings. Right, so here's my fishing boat. Now this is 80 kilometers away from port when it reaches its fishing grounds. So if I was to draw this, here's my fishing grounds right here. So I'm going to say this part right here is all my fishing grounds, right? Having reached its fishing grounds, the boat accelerates in a straight line directly away from the port as it catches fish. So that means the boat is going this way, it's accelerating. And we also have been given the acceleration equation, which is 0.5 kilometer per hour to the power of 2. Now the other thing is the speed of the boat is 3 kilometers per hour when it actually starts. So that means at this point right here, the velocity, and if we say it starts fishing, right? So we're going to put t as when it starts, when the fishing actually happens. So we have 0 is equal to 3. That's our kind of like thing that we need to know. Because when they can only fish when they reach the fishing grounds. So which means at this point right here, at the red line, their speed is 3. Now the question says, during which hour did the boat travel 11.75 k's? So think about it like this, all right? And I guess this is where how how do I say this? This is where it takes a bit of understanding some little tricks here and there. But I mean, I'm going to show you the long method first, because I think once you understand the long method, you kind of understand how to do the short method. Because the question here, it's not asking us at how much time had passed when it traveled 11.75. And I think that's the key thing to notice. It's actually during which hour did the boat travel 11.75. So think about it like this, all right? I'm running out of colored pens, but that's fine. So this line right here is when I'm going to put this as t is equal to 0, right? We know that the velocity is 3, and we also know the distance right now. We're not looking at the distance from the port. We're just looking at which hour did the boat travel at 11.75. So that means s is going to be 0. When t equals to 1, we don't know what s is. It's going to be something. But what we're going to figure out, like the question is trying to ask, is the question mark minus 0 equals 11.75? So obviously you're going to get like different types of question marks, right? Because like every hour it goes, we actually don't know what distance the boat has actually traveled between those between the hour mark. So in saying that, what we're trying to figure out is this 11.75, or is this 11.75, or is this? And so we're literally trying to figure out between which hour and which hour is it 11.75. So hopefully that kind of made sense. That's what they mean by when they say during which hour. So we're trying to figure out, is it between when t was 2 and 3, the distance is 11.75. So that's what we're trying to figure out. Okay, so what are some of the things that we need to get there? We actually need the distance formula. We've got acceleration formula, so we're going to use that first. So acceleration formula right now is a of t is 0.5. Now we know that when we integrate acceleration, we're going to get velocity. So velocity given time is 0.5 t plus c. Now here's the thing. We know, and I'm going to put this back here, we know that v of 0 is equal to 3. So we're going to use that to figure out what the value of c is. So if we go v of 0 is equal to 3, that means 3 is equal to 0.5 times 0 plus c. And so straight, you can kind of see that c is equal to 3. So here is our velocity function. Our velocity function is 0.5t plus 3. Now the next thing we need to do is to figure out what our distance function is. So s of t is equal to, we're going to integrate velocity function to get to distance function. So this is going to become 0.5t squared over 2 plus 3t plus c. Now also remember that we actually did say that s, when t is equal to 0, s was equal to 0. And so because of that, so we can actually write that here. Since s of 0 is equal to 0, therefore c is equal to 0. Now if you didn't understand what I did there, because remember, if I put s of t as 0 and t as 0, this becomes 0, this becomes 0, which means c has to be 0. So that's why I did that kind of like really quickly and put a little statement kind of like, since s of 0 equals 0, therefore c is equal to 0. So then here is my distance function. My distance function is s of t equals 0.5 t squared over 2 plus 3t. I can get rid of that 0.5 over 2 as 0.25. Let's just write that a little bit nicer. Cool. So once we've got this equation here, we're going to go, now it's a matter of like trying to figure out, is it s of 3 minus s of 2 equals 11.75? Or is it s of 15 minus s of 14? Is that 11.75? We don't really know. But what we do know is we can actually rewrite this as s of t plus 1 minus s of t equals 11.75. So what I've done there is that at any time, whatever t is, right, it's got to be 1 after that. That's why we write that t plus 1. And if we subtract those two numbers, it's going to equal 11.75. But we don't know what the t is, right? But what we do know is that it's t plus 1 and t. So in that case, we are actually going to write s of t. Now, we already know what s of t is because we actually kind of solved that here. So we can write that as minus 0.25 t squared plus 3t. Now, as for the s of t plus 1, we've got to figure out what t plus 1 is. And so wherever t is, we're going to replace it with t plus 1. So s of t plus 1 is going to be 0.25 t plus 1 squared plus 3 times t plus 1, and then minus s of t, which happens to be 0.25 t squared plus 3t, and all of this is equal to 11.75. Now I know it looks a bit crazy at the moment, but trust me, it'll actually work out quite nicely if you were to expand all of them. So we're going to expand the brackets. So we got 0.25 t squared plus 2t plus 1, and then expand the next lot of brackets. So we've got 3t plus 3, expand the next set of brackets, so minus 0.25 t squared minus 3t equals 11.75. So expand the quadratic brackets down here, so we're going to get 0.25 t squared. 0.25 times 2 is 0.5, so 0.5 t plus 0.25 plus, now 3t and 3t disappear. It's quite nice, don't have to worry about it. And what I've got left over is just 3 minus 0.25 t squared equals 11.75. And what you'll also notice is 0.25 and negative 0.25 t squared disappear. And we are simply left with, what are we left with? I hope I've not made a mistake here. No, looking good so far. I've got 0.5t plus 3.25 equals 11.75. So rearranging it, I'm going to get 0.5t equals 11.75. Take away 3.25. Which means I've got 0.5t equals, let's just do this. We're not going to muck around. Oh, sorry. Take away 3.25, 8.5. And then t is equal to 8.5 divided by 0.5, which gives us t is equal to 17. Okay, now we're not finished with this question yet, because remember, if you go back to the question, it actually says during which hour did the boat do that. Of course, I had to go too much. All right, during which hour? So we know that t is 17. So it is, when t is 17, t plus 1 is 18. So it's actually going between the 17th hour and the 18th hour. So we need to kind of say something like, in the 18th hour, boat travels 11.75 k's. So bit of a long question there, but that's what you get for a T2, as they call it in this, which are like a double excellence questions. Forms equation for distance traveled in 1 hour, but minor error made in the working leading to. So this is right. So you could potentially get a T1 for like a minor mistake. Finds correct distance equation gets you a merit. So that's up here, you get a merit. And then finds correct velocity gets you an achieved, which is there. So fairly long, you know, excellence question, considering I did the first 3 questions in like 15 minutes. But it's just what I'm finding is like these questions are taking, the excellence ones, taking definitely a lot longer to explain because there's just so much kind of like finicky little things that they start throwing in at the moment. But cool. All right, guys, let's go to question 2. Question 2, sketching like gradient functions. So I'm gonna be honest with you guys, like gradient function questions. I made a mistake here. I mean, I know it's just so hard to work with what do you call it, tablets. You know, usually when in an exam paper, you're gonna get your grid right below the function, so it's easy for you to kind of draw. So I guess I kind of have to go in this case just to show you guys what it looks like. All right, so the first thing to remember, and I guess this always works, right? So this is a shortcut that I tend to do. This shape right here is a cubic. All right, I know it's x cubed. Now, if I differentiate x cubed, I'm going to get 3x squared. Okay, I'm not worried about all the other things. All I'm looking at is the shape. This is a cubic goes like this, which is x cubed. And now we got a 3x squared, which means a parabola. That's what this shape's going to look like. The only thing that's really important to get in this gradient function is the turning points. So if you look at it, the turning point is somewhere halfway there and maybe somewhere here. So that right there is your 2 turning points. Now those 2 points, like because on your exam paper, this grid is going to be below this other grid. What I tend to do is like I take a ruler, and I'm going to see if there's like, oh wow, okay, cool, this actually is pretty neat. So I could actually chuck a ruler like this, all right, and I would literally draw the dotted line all the way down, and when I draw it all the way down, it's kind of going to look something like this. Okay, that's it. I can't believe I'm actually doing this, but this is kind of weird. So I would exactly do this, all right? So this is what I would do as well. I'll take a ruler and I'll literally draw it down. Now this one I got to do a little bit of counting because 4, 5, no, 1, 2, 3, 4, 5, 6, between 6 and 7. So somewhere around there. Right, so that was a bit weird, but you get what I'm trying to do, right? Like I'm just going to draw those straight lines down there. Now the thing is, here's like we know those green lines that I've drawn are the turning points, right? Which means the gradient is actually 0. So there's a point here, there's a point here when the gradient is 0, and it's a positive parabola, which means all you got to do is literally just sketch going through that point and sketch going through this point here. That's it. All right, that boom, there's your achieved right there. So using that ruler is a really nice little tactic. So you put the ruler and just draw your turning points straight down. That kind of gives you an idea of how to do this question there. Cool. Hopefully that helped. We'll go on to the second part of this question. Okay, so second part of the question is, what do we got? We've got x coordinate of the maximum point of the curve. Explain how you know the point is the maximum, not the minimum point. Okay, so all we're going to do is the first step is we're going to differentiate this function. So I'm going to write down f of x again. So f of x is equal to 2x cubed minus 42x squared plus 240x plus 8. If I differentiate it, I'm going to get 8x squared. No, I don't. Wow. 6x squared minus 84x plus 240. Now it's saying that I got to try and figure out what the coordinate for the maximum point is, right? So first I need to put this equal to 0 and solve it. So I'm going to put this equal to 0, 6x squared minus 84x plus 240. And again, when you have the graphics calculator, I'm not going to sit there trying to do the quadratic formula here or simplify. What, you know, just go straight into the graphics calculator, guys. Don't waste time with these things. So what are we doing here? Polynomial. Degree is 2, and we're going to chuck in those values. So we've got 6 minus 84, and we've got 240. Bang, there's our 2 values. We've got x equals to 10 and x equals to 4. So that's when the gradient is 0. Now there's lots of ways in which you can actually explain why one of them is going to be maximum or minimum. So the first thing to understand is that, as I said to you guys in the previous question, if you look at this right here, that is a cubic. All right, that's a positive cubic, which means it's going to look like this. And we have two turning points. These are our two turning points. And of course, the smallest number is going to come first, which is the 4. Oh, that's like a quick erase there. So we've got two turning points when x equals to 4 and when x equals to 10. And you can straight away see that x equals to 4 is what the maximum is. All right, so you can actually kind of do a couple of things here. You could find out what the y value is when x is 4 and x is 10, and then show that the y value for when x equals to 4 is higher. But I tend to go with the double differentiation because that's just easy, and it's something you're going to use in level 3 calculus anyway. So I'm going to differentiate the function one more time, and when I differentiate it one more time, so 6x squared differentiates to 12x, and then minus 84x differentiates to negative 84. Now, if you have, I'm going to put a little line here. If you haven't done double differentiation before, have a look at some of my calculus level 2. I think I did put a double differentiation one there, or even in the level 3 differentiation one. It's pretty straightforward, and it works pretty much all the time. So in this case, I'm going to put f double dash of 4 first. And I can see that 12 times 4 minus 84 is going to give me a negative value of negative 3436. And I can say since f double dash of 4 is less than 0, it has to be max. All right, as I said, the other way you could do this is you could actually find out what f of 4 is and f of 10 is, and you can actually go, okay, as you can see, f of 4 is higher than f of 10. Let me just show you guys how to do that quickly. All right, guys, quick little tip here how to do this one here. And again, like I'm sure there's another way, but like I haven't used this in a long time. So what you can do is, like, you know how you've got f of 4? So you can actually just go 4, put this little arrow and put that as x. So basically what it does is that x is now equal to 4. So just put in your equation. So you're going to get 2x to the power of 3 minus 42x squared plus 240x plus 8. So when x equals to 4, you can see that f of function is equal to, f of 4 is equal to 424. Then I'm going to change x to 10. So I'm going to put it as 10 is now x. And if I go back to that other equation and do that again, I'm going to get 208. So as you can see, 424 is actually higher than 208. That's another way you could use as well to say which one is max and which one is not. Cool. So merit is showing that maximum occurs at x equals to 4. And for achieved, you need to differentiate and equal to 0. Yep, and set to 0. Just differentiation is not going to get you an achieved in this. Cool. Let's go to the next question. Here we go. Another lovely velocity question, but this is not as complicated because all it's asking is acceleration when t equals to 2. So we're going to differentiate and we're going to find out what acceleration is. So remember that v of t is 3t squared minus 5t. So acceleration is going to be differentiation of that, which is 6t minus 5. And we're looking for acceleration when t is equal to 2. So 6 times 2 minus 5, which gives us 7. All right, and grades wise, this is an achieved question. Weird that I've seen, usually I see achieved questions coming at question B, not at C, but there you go, they're mixing it up. All right, we've got one more of these little sketch the graph kind of questions, right? As you can see, it's pretty hard for me to do, but I'm going to try my best here. Cool. So what we've got here for question D is we've got the gradient function. And again, as I said to you, this is a negative parabola. And if I integrate it, because if I'm correct, I'm supposed to draw the original function. If I integrate it, I am going to get negative x cubed over 3. So basically, I'm going to get a shape that looks like this. Cool. So what we have got is, first off, we're going to look at the turning points. Now, they've actually done the C already there for us, which is pretty good. Now, the next thing is, as I said to you, we're going to take that ruler. I can't believe I'm going to try and do this again, but let's see if this works. C. So as I said to you, you're going to have to like kind of, when you do that on the exam paper, it should kind of come up right there. So that's where that C comes. Next is we've got this little guy here, which we're going to draw. I believe that's about here. That looks about right. Yeah, 10. Yeah, 10 looks good. Okay, so that's another space. Actually, no, I should really draw that further down because I don't know where. Oh, you get the idea. Jeez. Trying to draw with these things is just like. So that's where my turning points are happening, right? So where the yellow line is. So what are some of the information that I know? It says the point C0 is on the graph. And it also says given that f of c is equal to 0, which means that f of c is equal to 0 is a turning point. All right, so that's this point right here. I'm going to show you guys where it is. So that's this point right there. Now the next turning point happens at the yellow line. All right, so that's the other thing that we need to know. And a maximum 10 squares to the right. Yeah, so we don't know where this turning point is going to be, but all we know is that it has to be above the red point. So the graph that we're going to be looking at is going to look something like this. So it's going to have a turning point here, and then it's going to go all the way there, but it's going to have a turning point. So that this point right here has to be a turning point. Okay, because the turning point is anywhere on the yellow line. So if you think about it, you might actually have a graph that looks like this. I'm going to show you all the different, I mean, there's any number of possibilities, guys. Like you could have a graph that looks like this. All right, so we don't know. All we know is that the maximum and the minimum has to come pop up on those yellow lines. So yeah, that's pretty much the shape. The shape looks like a negative cubic. So if you look at the answer schedule, it says that negative cubic with a minimum and x-intercept at C0, which is correct, and a maximum 10 squares to the right of x-axis. So this is where your maximum is. Along here, that's all looking good, except cubics that do not have a point symmetry. Yeah, this is like trying to be like symmetrical. Unlike, you want us to draw cubics and symmetry? That's just, yeah, no. No. So negative cubic gets you an achieved. So that's basically this shape there. The merit is you need to get those two turning points right to get a merit. So fairly neat little merit question because you can actually get merit like just by drawing a couple of things in this one. Okay, so let's go to question E. So question E, what we've got is we've got a cubic function, and it says that it has a turning points that occur at x equals 3 and x equals negative 5. So remember, the turning points mean the gradient is 0. So f dash of 3 is equal to 0, and f dash of negative 5 is equal to 0. So let's differentiate the function first. So when we differentiate the function, we are going to get 3ax squared plus 2bx plus c. Now the question is asking us to figure out an expression for C in terms of A, which means we've got to figure out a way to get rid of that B, right? And we've got to only have C and A. Now, using these two equations, so this is very similar to that simultaneous equations questions that we did back in question 1D, I believe it was, except in this case we've got letters. So I'm going to use f dash of 3 equals to 0 first, which means I'm going to get 0 is equal to 3a, x is 3, so that's going to be 3 squared, plus 2b times 3 plus c. So 0 is equal to 3 squared is 9, 9 times 3 is 27, so 27a plus 6b plus c. My first equation. Then my second equation is f dash of negative 5 is equal to 0. So 0 is equal to 3a negative 5 squared plus 2b times negative 5 plus c. So in this case, 0 is equal to negative 5 squared is 25. 25 and 3 is 75a. 2 times negative 5 is negative 10b plus c. Right. So that's the case. Let me just think if that's another way of... Yeah, I had a look at the answer schedule, and I think the second method will looks almost as, I think it'll actually be a lot more confusing, but that's fine. Let's just go with this one, right? Cool. So what we have is we've actually got two equations, right? So we've got 0 equals 27a plus 6b plus c. Then our next equation is 0 is equal to 75a minus 10b plus c. Now, if you look at the original question, it says c in terms of a, which means we need to figure out a way to get rid of, this lot, this b. We've got to get rid of them. All right. And so the way we're going to get rid of them is, and I think this is something that we talked about, manipulating equations and then eliminating the unknown. So simultaneous equations, that's what we're going to use. So what we're going to do is we're going to take this entire equation at the top here, and we're going to multiply it by, in this case, you can multiply it by negative 10. But know that between 6 and 10, the lowest common multiple is 30. So I'm just going to multiply it by 5. And take the next equation, and I'm going to multiply it by 3. So everything inside that green bracket, for the top one, I'm going to multiply by 5. Let me just do this in a different color. And for the bottom one, I'm going to multiply it by 3. So when I do this, I'm going to do the green one first. So 0 times 5 is just 0. 27 times 5 is 135a. And then 6b times 5 is plus 30b. And then I've got c times 5, which is 5. So just to clarify what I did there, I went this times this, this and this. So each one of those things I multiplied. And I'm going to repeat the same step, but this time with the 3. And when I do that, I end up with 0. 75 times 3 is 225a plus 30b. And then 3 times c is just 3c. And I realized I just forgot that 5c at the top there. And also that's got to be negative. Cool. So once I get all of that, what do I got here? I've got these two equations, and what I'm going to do is I'm just going to add them. All right? Because if I add them, then the 30b minus 30b will become 0. So I've got 0 plus 0 is just 0. 135a plus 225a, it's never, what do we got? 360a. 30b minus 30b is 0. And then we've got 5c plus 3c, which equals to 8c. So what we really have is 0 is equal to 360a plus 8c. Now we wanted the equation to be c in terms of a, so I'm going to rearrange this as 360a plus 8c equals to 0. So 8c is equal to 0. Take away 360a. And then c is equal to negative 360a divided by 8. So negative 360a divided by 8. Negative 360 divided by 8. That's going to give me negative 45. So in this case, c is equal to negative 45a. All right, so it's a little bit of manipulating simultaneous equations, but apart from that, it's not a bad E question. It's just you guys need to know stuff that you've simultaneous equations from level 1 when you manipulated 2 equations to get rid of a term. So this again happens to be a T2 question, like a double point, 2 points. So it's actually giving like 2 points for this excellence question. So you get like E7 and E8 for this question. So one of the excellence point comes from correct expression obtained, blah, blah, blah. So that's basically the end game right there. The second one is incorrect working or incorrect mathematical statements. So if you get the wrong answer, but somewhere you kind of like show the working somewhere here, potentially you could get an excellence for it. Forms the 2 equations utilizing the TP information. That gets you a merit, which would probably be forms 2 equations. So you would have to form that one and achieve this correct expression for f dash of x. So that's right there at the top. All right, so that's basically it for question 2, guys. We now move on to question 3. All right, guys, let's get going to question 3. What do we got here? Question 3. Okay. So question 3, what we've got is f dash of x, and it says that it goes to the point 310. Find the function. Okay, so we're just going to integrate this. So then f of x is going to be 3x to the power of 3, because 2 plus 1 is 3, and we divide by the new power, which is 3, minus 2x new power is squared, divide by the new power, which is 2, minus 4x, and of course, don't forget the plus c. So then we can say that f of x is equal to x cubed minus x squared minus 4x plus c. Now we've got to figure out what the expression is. So we know that f of 3 is equal to 10. So we're going to substitute 10 as f of x, and then we're going to get 3 cubed minus 3 squared minus 4 times 3 plus c. So we got 10 equals 27, take away 9, take away 12 plus c, whatever that ends up being. So what do we got? Negative 21, 6. So we can see that c is equal to 4. So we're going to write the equation down that f of x is equal to x cubed minus x squared minus 4x plus 4. And this is a lot of work for an achieved question, but hey, it is what it is, man. All right, so let's go to the next question here. Oh, here we go. What do we got here? I think it's a rate of change question. So we got a whale surfaces on a still sea, blah, blah, blah. Circular ripple expands outside. So I'm going to, again, just kind of like draw this out, right? So we've got like some sort of ripple that's happening. So constant speed, so that the radius of the circle is given by r is 0.7 t. Okay, that's fine. So this is the information that we've got. R is equal to 0.7 t. Now we're asked to find the rate. What rate is the area of the water within the circular rippling increasing 20 seconds after the whale surfaces? So I guess the first thing we got to figure out is at what rate is the area expanding. Now if you think about it like this, right? Area of the circle is pi r squared. So we're going to do that first. All right, let's just put that pi r squared. Now the next thing is, just want to see if this is going to still work. So since we know that r is equal to 0.7 t, we're going to substitute that in. So we're going to get a is equal to pi and r is 0.7 t squared. Now, the reason is because remember, you can't just differentiate area given with respect to r, because we are actually trying to figure out dA dt when t is equal to 20 seconds. All right. So if you look at it in the first line, I'm talking about this line here, there is actually no t. So we need to get rid of that r and replace it with a t in there. That's why I did it 0.7 t squared. So when we expand this, we're going to get, which is a is equal to pi. 0.7 squared is 0.49 t squared. So our area equation is equal to 0.49 pi t squared. Now we can differentiate it, which means we're going to get dA dt, which equals to 0.49 times 2 is 0.98 pi t. So that is our rate of change of area over time. The next part is actually figuring out what it is, right, at what rate it is. And we know that t is equal to 20. So we're going to put that in here, dA dt equals 0.98 multiplied by pi multiplied by 20. All right, and I think we should be good to go with that. 0.98 times 20, shift pi, that gives me 61.58. Area is, what do we got, meter squared? Yep, meter squared, and then it's over time. So we're just going to put meter squared over seconds. Now, in this question, it actually says units not required, so you don't need to worry about the units. Grades-wise, you're looking at a merit for the 61.58, and dA dt is going to get you an achieved. Now, going into level 3, if you're doing level 3 calculus, this predominantly is going to repeat itself. So I would actually spend some time doing, kind of getting the hang of this types of questions, because it definitely helps you guys at level 3, because in level 3 you start facing like 3 of them, and yeah, when you get to level 3 I'll show you guys. But yeah, that's basically it for this question here, and then we'll move on. It's one of these long questions, isn't it? Okay, so what do we got here? So we've got graph of the quadratic function together with its gradient function are given below. Okay, so this is h of x and h dash of x. So what are they asking us to find out? So they're asking us to figure out what the equation of h of x is. Now, here's some things that we know. All right, so I'm going to start writing these things down. So here, I know that h of 0 equals to 4. Yeah, that's really going to give me nothing. Here, I know that h dash of 0 is equal to 2, and h dash of 3 is equal to 0. All right, so what I'm going to do is I am going to actually get the equation of this straight line. So this straight line, and again, like if you've done equation of the straight line, like look, how do I say this? This is a pretty straightforward equation of a straight line, because we just need to figure out the gradient and the y-intercept, which is already given to us, which is 2. And if you look at the gradient, it is going down by 3, running across, sorry, going down by 2 and running across by 3. So we can straight away write the gradient function. It is going to be negative, so rise over run x, that's h dash of x equals to the gradient x, and it doesn't have 2 is the y-intercept, so there's my equation right there. Now, if you were like, oh man, I can't remember how to do the straight line friggin' thing, just remember, again, you got your calculator, so go into stab mode, all right, chuck in 0 and 2. What do we got, 3 and 0 after that? Yep, 3 and 0 after that. And just click on graph 1, calc, and x is what you want. So there you go. A is negative 0.666, same thing as saying negative 2/3, and B is 2, that's your y-intercept. So if you forgot it, just in case. Cool, so we've got our equation, which is h dash of x is equal to negative 2x over 3 plus 2. So we're going to integrate it. So when we integrate this, we're going to get negative 2x squared. And of course, there's still a 3 down at the bottom there, so it's going to become 3 times 2, plus 2x plus c. So h of x is equal to negative x squared over 3 plus 2x plus c. Now here's the kicker. We already know what the c value is, because remember, c is the y-intercept, and in this case it's going to be 4, so we can just write h of x is equal to negative x squared over 3 plus 2x plus 4. And I would also put that in a statement since h of 0 equals to 4. So grades wise, we are looking at a merit grade for the answer here, anti-differentiation. Integration gets you an achieved, so that's probably somewhere here. So it's still your standard type of question, but it's just that extra step that you have to do, which is come up with the equation of the gradient function, which is that straight line. Which kind of sucks. I mean, like, just asking you to do the same thing. Oh, well, moving on. So next question, what we have is we've got a straightforward function, which we're going to write that down. It just makes it easy for me. So we've got kx cubed plus 9x has a tangent with a gradient of 15 where x equals to 2. So in other words, f dash of 2 equals 15. And we've got to figure out what k is. Okay, so we're going to differentiate this. So when we differentiate this, we're going to get 3kx squared plus 9. And we know that the gradient at 2 is equal to 15. So remember that, f dash of 2 equals to 15. So I'm going to put 15 on the left-hand side. And wherever x is, I'm going to put that as 2. And here is my lovely equation. So I've got 15 equals 2 squared is 4. 4 times 3 is 12. So 12k plus 9. Rearrange that. So 12k plus 9 equals 15. Again, I have to carry on here. Just trying to. So 12k equals 15. Take away 9. 12k equals to 6. And k is equal to 6 over 12, or 0.5. That's not a bad merit question. Like, fairly straightforward. Just differentiate and then substitute. Oh no, I was wrong. Geez, I thought it was a merit question, but it's not. It's actually just an achieved question. I was wondering. Yeah, what's up with these guys putting like question D's, achieved questions like at D's? Normally they put it as A and B's. It's not fun when they start to kind of like mess around with that. Never too much fun. All right, guys, so we go to the last question, and hopefully my voice is still kicking after that, just for the last one anyway. Whew. That looks like a fun question. Yeah, I think it's a good time you pause. Okay. Point is it, blah, blah, blah. Yeah. Okay. All right. So what they're asking us in this question is they're not asking us to find what the maximum area is. They're just asking us to find an expression. All right. So how do we go about doing this? As you guys can see, they've given you some little hints here. They want to know what's the biggest triangle that's going to fit inside the shape, right? So I'm just going to kind of like highlight one triangle to work with so that it kind of makes a bit more sense for you guys. Okay. And this is a really cool kind of question, because I mean, I know that before they used to be like merit questions, but I can see what they try to do here. So what we have is we've got this triangle, right? Now the first thing you need to remember is area of a triangle is half times base times height. Okay, so the first kind of idea that you need to have is the base of the triangle is this part right here. Then the height of the triangle is this part here. Now think about it like this, all right? If I was to look at just this point here, this point right now, I'm going to say that's point X and Y. I hope you guys can see that, because X is from here to here, wherever X is, and then Y is from there to there. So in other words, I can see that the base of the triangle, the distance is actually X, and the height of the triangle is actually Y. So I hope that actually kind of makes sense. And I will run some tutorials later on in the year when I kind of go through this part again, because this is something quite crucial to know. So yeah, that's pretty much what I've done here, right? So I'm just going to write that down here. So area is equal to half, base is x, and the height is whatever the y value is. Now, because I know that y is equal to mx minus x squared, I can get rid of the y and replace this with a is equal to half times x multiplied by mx minus x squared. So basically what I've just done here is that yellow triangle, whatever the triangle is, I've just given the equation for that. Now remember, if I want to find out what the maximum possible area is, I've got to differentiate this function, put it equal to 0, and then once I put it equal to 0, I get an x value, substitute it back into the original, right? So that's pretty much what I'm going to do. So first thing I need to do is expand this area function. So I'm going to get half mx squared minus half x cubed. So that's my area function. So I'm going to differentiate the area. Half times 2 kind of disappears, so it just becomes mx minus 3 over 2 x squared. So here is where my differentiated function for the area is. So I know that max or minimum happens when the gradient function equals to 0. So I'm going to put this equal to 0, and I'm going to get mx minus 3 over 2x squared. Factorize the x, so I'm going to get x m minus 3 over 2x. So basically at this point I've got x is equal to 0, or m minus 3 over 2x is equal to 0. So basically it's just saying that this is when maximum or minimum is going to happen. All right. Now think about this. X can't be 0. You can't have a base of 0. So you straight away say base equals 0 is not possible. Therefore, x is not 0. So we're going to kind of like ignore x equals to 0 and just focus on the other one. So when we rearrange the other one, we're going to get m is equal to, let's actually do it this way, negative 3 over 2x equals negative m. And then I'm going to get rid of the 2 to the opposite side. So I'm going to get negative m multiplied by 2, and I've got x is equal to negative 2m divided by negative 3. Or in other words, maximum happens when it's 2m over 3, when x equals to 2m over 3. So all I've figured out is what is the value of x when the maximum area happens. Now, if you think about it, the question is actually asking what is the maximum possible area. What I've just figured out is the value of the base where the maximum possible area is going to happen, which means I need to go back and substitute where the original area function. Remember, the original area function is area is equal to half mx squared minus half x cubed. So this was my original area function. And what I need to do is I need to actually replace wherever x is with 2m over 3. So what we got here is then area is equal to half times m multiplied by 2m over 3 squared minus half 2m over 3 cubed. So in the first instance, I'm going to get 2 squared is 4m squared over 9 minus half times 2 to the power of 3 is 8m cubed over 3 to the power of 3 is 27 is what I'm looking at. Simplifying the numerator on this side, 4m squared times m is 4m cubed divided by 9 times 2, which is 18, minus 8m cubed over 27 times 2 is 54. So common fact, I'm going to kind of expand this. not expanded. I'm going to put them under the same denominator. So I can see that 18 times 3 is 54, times 3 is also, I've got to do it at the top. So I'm going to get 12m cubed over 54 minus 8m cubed over 54. So 12 minus 8 is 4m cubed over 54. And of course, this simplifies to 2m cubed over 27. So it's not a, like, to be honest, guys, it's not a bad excellence question. It's just a lot of algebraic manipulation to it. But the idea being is that, you know, you've got to get that initial concept of how to set up that equation of area is half times base times height, and then trying to figure out that the base is actually x, and then the equation of y is the height of the triangle. Because think about it like this, all right? And I know I'm kind of going back to the beginning, but if you look at that second triangle, right? Like if you look at that orange triangle, then you can kind of see that x, the base, is all the way there, and then the height is going along the parabola itself. So that's why I don't want to kind of like color it up too much. So grades wise, correct expression obtained is excellence. So boom, get that. It's another T2 question. So like 2 excellence grades. You get it fully correct, you're going to get like 8 points. Otherwise, you make a minor error, you could get like E7. So let's say you make a mistake somewhere there, you could still get like a T1, I think, just E7 points. I don't even know how to grade these things anymore. Find MRX. So MRX, so that's going to get you a merit. I don't know what they mean by MRX. Okay, I see what you mean by, so you can actually have it like rearranged. Correct differentiation of an expression for the area. So that would be up here is where you're going to be getting an achieved. Yeah, so it's not a bad paper. I know it took me a lot longer in that question 1E, but apart from that, it was not too bad. Okay, so guys, that is basically it for this pretty long video. I don't know how long that is, but that's basically it. Just kind of like my final thoughts, or like final ideas or suggestions. Especially with level 2 calculus, don't leave any kind of questions empty. Just, I think your first idea is like try and have a look at it. If you don't understand what to do, see if you can integrate it or differentiate it or whatever you think that the question's actually asking you. My advice to people doing calculus is like, don't leave anything empty. Always make sure that you attempt everything, really. Like, don't leave any question empty. But apart from that, I think that's it from me. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.